Hello, welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for physics for the year 2012. This is the second part of the recording. We are going to be looking at the next or the last 25 questions for this year. If you are new to the channel, don't forget to subscribe to our channel, like and share our content. You can also visit our website at scholar.com to practice the UTME exam and modular quizzes for free. First question here: the equation of a wave traveling in a horizontal direction is expressed as y equals 15 sine 2 omega sine 2 pi over 5 in bracket 60 t minus x. What is its wavelength? Right, to solve a question like this, we are going to compare this given equation, okay, this wave equation that's given here, to another standard wave equation, to the standard wave equation. Okay, so this is what we have from the question. Okay, but we also have this y to be equal to a sine 2 pi over lambda in bracket vt minus x. So if you relate this now, okay, what we are looking for is this lambda here, this wavelength. So if you relate these two, you see that we have 2 pi over 5, okay, and here we have 2 pi over lambda. So we say 2 pi over lambda is equal to 2 pi over 5. Okay, if you cross multiply both sides, that is, you use this denominator here to multiply the numerator here, and this denominator to multiply the numerator here, then we are going to have the 2 pi times 5, that will be 10 pi, is equal to 2 pi times lambda, and that will be 2 pi lambda. Then to get the value of lambda, this wavelength here, we will divide both sides by 2 pi. If we divide both sides by 2 pi, then we'll be getting lambda to be equal to 5 meters. So that is our wavelength. The other thing that they could have said we should calculate velocity. This velocity v here, you just compare it to what you have here. You see that your v here, instead of v you have 60 here. That means the velocity of the wave is 60. They could ask you to find the amplitude, which is this thing here. Okay, so the amplitude here is 15. They may even ask you to find the frequency. Alright, to find the frequency, you will use, if you are given an equation like that, you have to find the frequency. The first you have to find is the velocity, which here is 60, and the wavelength, which here is, we calculated it to be 5. Okay, you then say that the frequency is equal to the velocity divided by the wavelength. So that will be 60 divided by 5, and that will be 12. So there are many ways this question can come, and there are many forms as well that this standard equation can come. We have a sine 2 pi, okay, 2 pi f in bracket, 2 pi in bracket, you have omega theta, or a sine in bracket omega theta minus 2 pi x over lambda. That's another. There are many forms basically. From the diagram above, if the particles f is at distance x from O to the right, the phase of the vibration will be different by that of O by. Alright, the phase difference, okay, the phase difference phi in a progressive wave equation is given as 2 pi x over lambda, 2 pi x over lambda, where the lambda is the wavelength. Which of the following factors will not affect the velocity of sound? That is wind. Okay, wind traveling in the same direction will affect the velocity of sound. So wind, humidity, density of medium, and temperature, they are factors that can affect the velocity of sound. Next question: the characteristic of a vibration that determines its intensity is the amplitude. Okay, the amplitude. The intensity of sound varies directly as the square of the amplitude of the sound. So amplitude will affect amplitude will determine the intensity. Where can a man place his face to get an enlarged image when using a concave mirror to shave? The man should place his face between the principal focus and the pole. Okay, between the principal focus and the pole. When an object is placed between the principal focus and the pole of a concave mirror, then a virtual image, which is erect and enlarged, is going to be formed. Okay, so for the man to get an enlarged image when using a concave mirror, he should place his face between the principal focus of the mirror and the pole. A pinhole camera is placed 300 meters in front of a building so that the image is formed on a screen 5 centimeters from the pinhole. If the image is 2.5 centimeters high, the height of the building will be. Alright, the object distance. Okay, the distance of that the object here is the building. So the distance between the building and the pinhole camera is 300 meter. He said it is placed 300 meter in front of the building, so 300 meter away from the building. All right, that is the object distance. The image distance is the length of the pinhole, okay, or the distance between the pinhole and the screen in the pinhole. That is 5 centimeter here. Since our object distance is in meter, our image distance should be in meter, so that we can have a balanced unit here. So we would convert this to meter by dividing by 100, and we have 0.05 meter. Now they said if the image height, you have the image height to be 2.5 centimeter. Okay, that's the image height. We also convert this to meter by dividing by 100. The question is now to find the object height. For this, we are going to use the formula for magnification. The formula is next, the magnification of an object 2 centimeter tall when placed 10 centimeter in front of a plane mirror is. So for a plane mirror, okay, the plane mirror does not magnify or diminish an image. Okay, it will produce an object rather. It will produce an image that is of the same size as the object. Okay, the image that it produces is of the same size as the object, and thus the magnification of a plane mirror is 1, meaning it will produce, objects that an image that will be of the same size as the object. No magnification. After reflection from the concave mirror, rays of light from the sun converge. They will converge at the principal focus. Okay, now this is one of the methods that is used to determine the principal focus of a concave mirror. Okay, so the concave mirror is made to face the sun. All right, now the point where the light is that are now coming from that sun converge after they reflect from the concave mirror is what gives us the principal focus of the concave mirror. So this is one of the ways, okay, to find the concave mirror, to determine the concave mirror. To determine the principal focus, okay, and the focal length of a concave. A glass block of thickness 10 centimeter and refractive index 1.5 is placed on an object. If an observer observes the object vertically, the displacement of the object is. Alright, refractive index is real depth over apparent depth. Okay, real depth over apparent depth. Now the refractive index of the material here is 1.5, equal to the depth is the thickness of the block. Okay, the thickness of the block, which is 10, divided by the apparent depth here. So when you cross multiply this, you have 1.5a to be equal to 10. To get the value of the apparent depth, then we divide both sides by 1.5, and that will give us 6.67. Okay, now the vertical distance is now going to be the real depth minus the apparent depth, and that will be 10 minus 6.767, and we are getting 3.33 centimeter. Next, on light, which of the statements above are conditions for total internal reflection to occur? So there are two necessary conditions for total internal reflection to occur. One is that the angle of incidence, the light ray should be traveling from a denser medium to a less dense medium, which is what you have in this statement here. So this is correct. The second condition is that the angle of incidence in that denser medium should be greater than the critical angle. The use of lens is not applicable in the periscope uses plane mirror. Okay, it uses a mirror, it does not use lens. Dispersion of white light is the ability of white light to, that's its ability to separate into its constituent color. Okay, these 7 colors, they make up the white light, the white light. Roy beef. Okay, this is I, red, orange, yellow, green, blue, indigo, and violet. So dispersion of white light is the split of white light into this color. Next question: a newly charged 12-volt accumulator can easily charge a car, whereas 8 new dry cells in series with an effective EMF of 12 volts cannot start the same car because. This is because the current capacity is low in them. Okay, the current capacity is low in those 8 dry cells connected in series. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry, and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. freebies are also available to top performance on the website. 6 identical cells, each of EMF 2 volts, are connected as shown. The effective EMF of the cell is, it will be the sum of the EMFs, that EMF of each of these cells that we have here. So we have 6 cells and each of them has an EMF of 2 volts. So the total or effective EMF is going to be 2 plus 2 plus 2 plus 2 plus 2 plus 2, or we simply say 6 times 2, that will be 12. The fuse of an electric device is always connected to the live side of the electric supply. Okay, it is connected to the live side of the electric supply. Now what the fuse does is that it helps to check for the current. Okay, it helps to check for the current. In the advent of an excess flow, when you have excess current flowing to the circuit, then the fuse is going to cut, okay, or it will blow to prevent that that charge from destroying the appliance. Next, on electric field, a particle carrying a charge of 1.0 times 10 raised to power minus 8 coulombs enters a magnetic field at 3.0 times 10 raised to power 2 meters per second at right angles to the field. If the force on this particle is 1.8 times 10 raised to power minus 8 Newton, what is the magnitude of the field? So we say the force in that field is equal to BQV sine theta, where this B is the magnitude of the field, Q is the charge, V here is the potential, is the velocity, and this theta here is the angle. Okay, that is the angle of the charge to the field, and here we are given as it says the charge enters at right angle to the field, so the theta here is 90 degree. Okay, the right angle is 90 degree. All right, sine theta here is going to be sine 90, and sine 90 is equal to 1. So this formula here is going to reduce to BQV. Okay, since the sine theta, that is sine 90, is 1, we just have F is equal to BQV. In the question, we have to calculate the magnitude of the field, which is this B. So to get that, to obtain that, we are going to divide both sides by QV. So we are going to have F over QV is equal to B. Okay, so B is equal to F, the force, which we are given in the question as 1.8 times 10 raised to power minus 8 Newton, divided by the charge. Okay, the charge, which is 1.0 times 10 raised to power minus 8, multiplied by the velocity. Okay, which is 3 which is 3.0 times 10 raised to power 2. So here we have 1.8 times 10 raised to power minus 8 over 1.0 times 3 is 3 times, we use the law of indices on this. 10 raised to power minus 8 times 10 raised to power 2 will become 10 raised to power minus 8 plus 2, and so this will be 10 raised to power minus 6. Now at the numerator, what I'm going to do here is this: I'm going to take 1 10 from here. I'll take a 10 from here. So if I take a 10 from here, this will become minus 9, meaning this is already minus 8. I'm now taking 1 10 again from it, so it will become minus, like minus 8 minus 1. So this will be 10 raised to power minus 1. That 10 that I've taken from here, I'll use it to multiply this 1.8, and so we have 1.8 times 10, and that will be 18. Okay, then to do this division, I will say 3 in 18 is 6. Then we use our law of indices on this here. 10 raised to power minus 9 divided by 10 raised to power minus 6 is going to be 10 raised to power minus 9 minus 6. Okay, minus 6 will become plus 6. That is minus times minus 6. That will become plus 6. So I'm going to have 10 raised to power minus 9 plus 6, and that will be 10 raised to power minus 3. Okay. Which of the following is a correct shape of the graph of capacitive reactance XC versus the frequency for a pure capacitor in an AC circuit? Alright, that will be D here. Okay, that will be D. Now the capacitive reactance, okay, the capacitive reactance is given as 1 over omega C, where this omega here is the angular velocity and C here is the capacitance. Now the angular velocity is given as 2 pi f. So if you substitute that here, we are going to have 1 over 2 pi f c. Alright, so from here we see that S sub c is inversely proportional to what? To the frequency. It varies inversely as the frequency. What that means is that as this increases, the value of the frequency decreases. And so this graph here, okay, this graph here with this graph here, you have a downward slope from left to right indicates inverse proportionality. Okay, so this here correctly represents the shape of the graph of capacitive reactance against frequency. Next, the current output form of an AC source is given as 1 is equal to I, the root mean square value of the current, is equal to 10 sine omega t. The DC equivalent of the current is, that will be the root mean square value of the current. Okay, it will be the root mean square value of the current, and the root mean square value of the current I is given as I naught, that is the peak value of the current, divided by sine divided by root 2. Okay, divided by root 2. Now I is equal to I naught sine omega t, that is the root mean square value of the current is equal to the peak value sine omega t. If you compare that to what we have been given in this question, that means that our I naught, okay, the peak value of the current here is 10. Okay, comparing this equation to this, the peak value of the current is 10. You will now come back to use this formula here, that the DC equivalent of the current is equal to the peak value, which is 10, divided by divided by root 2, and root 2 is 1.414. So we have 10 divided by 1.414 to be 7.1 ampere. Next question: a conductor of length 1 meter moves with a velocity of 50 meters per second at an angle of 30 degrees to the direction of a uniform magnetic field of flux density 1.5 webers per meter squared. What is the EMF induced in the current? Alright, the EMF induced in the current is given as B, okay, the magnetic flux density times the length of the conductor times the velocity, okay, the velocity sine theta. So from the question, we have the length of the conductor as 1 meter, the velocity is 50 meters per second, the angle theta is 30 degrees, alright, and the magnetic flux density B is 1.5. So you substitute all of that into this equation here. We have B 1.5 times the length, which is 1 meter, times velocity, which is 50 meters per second, times sine 30 degrees. Sine 30 degrees is equal to 0.5. So when we evaluate all of this here, we are going to be getting 37.5 volts. The process of detecting a pin mistakenly swallowed by a child, okay, is using X-ray is, it is called crystallography. Okay, crystallography. It is the use of X-ray or electrons to determine the position of a crystal in the body. So we want to use that X-ray to determine where is the position of this solid here, this pin here, in the body of that child. Okay, so that process is what is called crystallography. It is used to determine the position of a crystal or a solid in the body of the in the body or in the structure. Okay, you can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2 or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, you could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. Which of the following particles cannot be deflected by both electric and magnetic field? That is the gamma rays. Okay, the gamma rays are neutral, they carry no charge, and as such they are not deflected by electric and magnetic field, or like alpha particle, beta particle, and wave particle. Now wave particle is too general. A piece of radioactive material contains 1000 atoms. If its half-life is 20 seconds, the time taken for 125 atoms to remain is. Now the half-life of a radioactive material is the time that it will take for it to contain half of the original number of particles that it has. That is the time that it will take for it to decay to half of its original size, okay, or mass. Now this radioactive material contains 1000 atoms, and they said its half-life is 20 seconds. What this means is that after 20 seconds, half of these atoms will be lost, okay, and it will remain like 500. All right, half of it will be lost. So this radioactive material will get to half of what it has originally. So that means that after 20 seconds, it is now going to have 500, 500 atoms. So the time taken for 125 atoms to remain that is what we have to find. Alright, a very simple way to do this is this. We said half-life is the time that it will take to remain half of what is there originally. This means that in 20 seconds this is going to remain 500. In another 20 seconds it will remain 250. In another 20 seconds it will then remain 125. So if you look at how many seconds did it take, okay, to remain that 125, that will be 20 seconds to 500 to remain 500, another 20 seconds to remain 250, and then 20 seconds to remain 125. So it's taking a total of 20 plus 20 plus 20, that is 60 seconds. Okay, so another way is to say, right, the first time after the first decay, after the first 20 seconds, it remained 500 atom. After the second decay, it remained 250 atom. After the third decay, it remained 125 atom. So the total time is going to be, how many times did it decay here? 3 times. It should now be 3 times the half-life of that material. So that will be 3 times 20, and that is 60 seconds. The p-n junction diodes can act as rectifiers because the p-n junction diodes can be used as rectifiers because they conduct current when they are forward biased. Okay, they are used as rectifier, allowing the flow of current in one direction. Okay, so the p-n junction, it allows for the conduction of current when it is forward biased, and it reverses when it is reverse biased. Okay, when it is reverse biased, it resists the flow of current, but when it is forward biased, it conducts current. Now what we call rectification, okay, is the conversion of an alternating current into a direct current. Okay, so what we are saying is this p-n junction diode is used to convert alternating current to direct current when it is forward biased. If a reverse bias voltage is applied across a p-n junction, the depletion layer width is the width of the depletion layer is going to increase. Okay, if a reverse bias voltage is applied to a p-n junction, okay, the depletion layer is going to widen, meaning it will increase. Which of the above are advantages of semiconductors? So semiconductors are usually of small size. Okay, they have low power input, they require low power input, all right, low power requirements, and they are highly durable. Okay, but it can be easily damaged by high temperature. Okay, their accuracy is affected by temperature. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Scholarfedu. Okay, like and share our content, and visit our website at scholar.com to practice UTME exam and modular quizzes for free. Thank you.